Hello everyone, welcome to this new video where we are going to go through minimum falling path sum. So basically here we have a matrix, so it's an array of size n times n, so it is a square matrix we are looking, and we are supposed to find out what is the minimum sum of falling path through matrix. So now the question is, what is a falling path? So it has been defined that the falling path starts at any element in the first row and choose the element in the next row that is either directly below or diagonally left or right, especially the next element from position row call will be row plus 1 call minus 1, row plus 1 call, or row plus 1 call plus 1. Interesting. So that means if you are trying to construct a falling path, let me take this. If you are trying to construct a falling path, this is a falling path. Let me take a color. This is a falling path because you are moving from here, you go here, you go here. This is a falling path. This is a falling path. You see, this is a falling path. So a falling path is basically like I would say a line that you can draw from the first element to the last element, knowing that each element should be tied with the element directly before him, or diagonally left or diagonally right. So this is not a falling path because this one cannot be tied to this one. This one can only be tied either to this or this. And then now that we are aware of what is a falling path, now our goal here is to find the minimum sum of any falling path. So basically we are supposed to compute all of the falling path, the possible falling path, and return the minimum. So my idea of computing this will be as follows. To compute the minimum sum of falling path, first what I will do is that I will consider the element at the top like to be my base cases because I'm starting with them. And then while moving, for each of the element, I'm going to take in consideration that this element can be tied either to the element directly on top, directly to the left, or directly to the right. So I'm just going to find the minimum of those three, and I'm going to tie it to this, the same here, and then the same all over. Let us implement and see what it gives. Let's say I'm here. Let me take a color. Let's say I'm here. So here I initially have 6, right? This one I'm going to check. I'm going to have my first value, which is going to be equal to the element directly on top because I know it always exists. This is 2. Now I'm going to check. This one can be tied also to the element to the left. Is this one less than the value that I already have? Yes. So the value will now be 1. Is this one less than the value I have less than the one directly to the right? It doesn't even exist, so there's no comparison to make. So at this point the value here should be equal to the value that I have, like the falling path ending here, the minimum falling path ending here is the value that I have plus this v. So at this point this one is going to be 7 at this point, so we should have 6 here. The same, we are going to do the same here. Here we have a 5, right? We initially have a 5. This is what we have initially. Now we are going to check the same process. We are going to do the same process. Like v is going to take this one 1. Now we are going to check, is this one actually smaller than the v? No. Is this one smaller than the v? No. So the v will definitely keep the value 1. So what we are going to do, we are just going to say this one is going now to be 6. The same here, it is starting with 4. So we are going to say, okay, we are starting with 4. 4, the initial value we have is 3. For the value that we are going to append is 3. Now we're going to say, do we have a right element? No, there's no right element. Do we have a left element? Yes, there's a left element. Is the left element smaller than the right than the value we already have? Yes, it is smaller. So at the end of the day, the value we are going to add here is going to be 1. So this one is going to be transformed into a 4 plus 1, which is a 5. So at this stage, this is actually the minimum falling path ending at this row, right? We are going to continue the same here. So here the value is 7. We are going to find what is the minimum value. So let me just put them so I don't have to write them twice. Okay, so the value here is actually 7. Now you are computing the minimum value, the minimum falling path at this row and then at this column. So you are going to first check this is the first value 7. You're going to check, do we have a left element? No, we don't have. Do we have a right element? Yes. Is the right element smaller than the value we have? Yes, it is smaller. So our value at this point is going to be this, which is 6. Now you're going to say, okay, instead of the 7 here, you're going to have the 7 plus 6, which will give you 13. Now we are going to continue the operation. Here we are at 8. We are going to check the value is going to take initially 6. Now you're going to check is the 6 actually smaller than the value at the left, which is 7? No. Is the 6 actually smaller than the is the 6 actually smaller than the value at the right? No, it is bigger. In fact, you are searching for the minimum at the left and the right, and at this case it's actually 5. So you're going to see this one is going to take now 13. Now you have 3. 3 can go with either 6 or 3 can go with 5. Now you are going to check, is the initial value here is 5. Do we have a left? Yes, the value of the left is 6. Now you don't need to take it because 5 is the smallest value you can have. So at this stage you are going to have an 8 here. Is that clear? So basically this was the example I was going through. So I used 3 instead. I used 3 instead of 9. Let me use exactly the example to understand how they end up with that result. So let us take, it was 9 here. Yeah, 7, 8, 9. So this is a 9. But initial is actually the same logic. So if I'm keeping a 9 here and then here I'm putting my 9, you are going to see that the value here will be actually equal to 9 plus the minimum of those two, which is 9 plus 5, and the 9 plus 5 will give you 14. And you do agree with me that the solution is actually 13. It can be this one or this one, I don't care. So I'll just keep the solution like this. So I'm going to return 13. So this is my approach of solving this. My approach of solving this is basically like looping from the second row to the last one, and for each of the row update the value at that position by giving to that value the value corresponding to him plus the minimum possible that he can have, and the possible solution are actually only the one directly on the top, the left and the right. So I'm just checking for the minimum of those 3 and append it to this one and apply this till my array, till I'm the end of my array. And once I'm the end, the only thing I need to do is to find the minimum around the element of the last row, and here I can return any of them. So what would the implementation look like? So the implementation will be as follow. So I'm just computing the size of the matrix here because I don't want to repeat myself computing that many times. So I'm just looping from the first row, like I said, instead of row 0, I'm starting from the row 1. And for each of the row, I'm going to loop through all of the elements. I'm 100% sure that the element directly on top will always exist, right? Because I'm at the first row, so I will always have row minus 1. So when I'll be here, this will be the n minus 1. When I'm here, this is the n minus 1. So I'm 100% sure. That's why I'm taking my value as the value directly on top. Now I'm checking if I'm not at position 0, that means I will have an element to the left. But if I'm position 0, there's no element to the left. That's why I'm checking. If I'm not at position 0, Then I'm going to also take in consideration the element to the left and apply the minimum. So v will keep the minimum of those two. If I'm not at the last, I will have an element to the right. So if I'm not at the last, I'm just like also do the same. V will take the minimum, and at the end, the value of the matrix at that position is going to be append, like it's going to be increment with the value of the maximum that I had on top. So at the end of the day, this matrix is going to be equal to exactly this matrix. The last thing you need to do to find the minimum, really up to you. I decide to use C++ built-in function to find the minimum element in an array, and here my array is the last array of the matrix. So just taking the minimum and returning the value pointing to the minimum. Let us run and see what it gives. Yeah, so you can see we are passing all the test cases. So this was my approach of solving this. I hope you do enjoy it. Feel free to leave me any input. I'll be really happy to interact with you regarding this. See you on the next video. Ciao.